So, picture this. It's 2026. There's one company that suddenly feels like it's everywhere. In your newsfeed, powering the AI that writes your emails. Its stock price is doing things that make roller coasters look tame. That company is Nvidia. Wondering how a company you knew for making games suddenly sits at the center of the biggest tech revolution since the internet? You're in the right place. This isn't just about computer chips. It's about seeing the future before anyone else did, making massive bets, completely changing the game. Nvidia's journey started in a simpler time. Back in 1993, a group of engineers, led by a guy in a now famous black leather jacket, Jensen Huang. They wanted to build specialized chips to solve a niche problem, make computer graphics better. Every great story has a beginning, a moment where things really kick off. For Nvidia, that moment arrived in 1999. Before then, they were one of many scrappy startups in a cutthroat hardware world. Then came GeForce 256, the product that changed everything. Nvidia marketed it as the world's first ever GPU. Brilliant marketing backed by serious technological muscle. It rendered millions of polygons per second and handled complex lighting and transforms on its own. For gamers, it was a revelation, from slideshow to immersive fluid 3D worlds. Demand exploded. Gamers began building their PCs around Nvidia's hardware. They found their tribe and built a brand. GeForce became synonymous with high performance. A loyal fan base, hungry for the next chips. This success gave Nvidia two crucial things. First, a steady, profitable revenue stream to fund R&D. Second, relentless gamer demand. Better graphics, higher frame rates, more realistic physics. It forced a cycle of rapid innovation. Faster, more efficient, more powerful chips. Designing for complex parallel game worlds made them experts in parallel processing, the secret sauce that would later unlock entirely new industries. For years, Nvidia's GPUs were like Formula One race cars, built for one specific track, rendering graphics. Amazing at what they did, and that was all they did. In 2006, Nvidia made a giant leap. They released CUDA, Compute Unified Device Architecture, a software platform, a universal translator letting developers speak directly to the GPU. Now, its parallel power could be used for anything. Break big jobs into thousands of small tasks, processed in parallel. Suddenly, the GPU wasn't just for graphics. With CUDA, the engine for rendering fantasy worlds powered scientific simulations, financial modeling, and complex data analysis. This was a monumental shift. For the first time, thousands of GPU cores were harnessed for general-purpose computing. Risky and visionary, few were asking for it. CPUs dominated HPC. Nvidia invested in libraries, tools, and tutorials, building a bridge to a new world. Researchers crossed it. Tasks that took days on CPUs finished in hours on GPUs. From medical imaging to weather and drug discovery, CUDA created a moat around Nvidia's hardware. Not just fast chips, a software layer and community competitors couldn't replicate overnight. As the 2010s kicked into high gear, another massive wave rose. Cloud computing. Amazon, Google, and Microsoft built colossal data centers worldwide. Not just for your vacation photos, the backbone of the internet. Businesses moved from clunky servers to scalable cloud infrastructure. The demand for computing power became insatiable. Hundreds of thousands of servers needed the fastest, most efficient chips. CPUs led at first, but Nvidia, armed with CUDA, saw a huge opportunity. GPU compute was perfect for massive cloud workloads. Nvidia pivoted to specialized server GPUs, built for horsepower, efficiency, and reliability. Designed to run 24/7 in anonymous humming racks. They struck major deals with all the big cloud providers. Soon, if your cloud job needed serious number crunching, chances were an Nvidia GPU did the heavy lifting. powering everything from Netflix recommendations to Wall Street algorithms. The data center move transformed Nvidia from gaming company to computing platform company. That pivot positioned them perfectly for the next, even bigger wave, and honed the most valuable skill in tech. If CUDA opened the door and the cloud built the highway, artificial intelligence became the destination. By the mid-2010s, deep learning delivered astonishing results. It recognized faces, understood speech, and translated languages in real time. But training these models required staggering amounts of math, impractical on traditional CPUs. Researchers realized GPUs' thousands of parallel cores were perfect for deep learning's math. The same tech rendering realistic shadows could train neural networks, a perfect match. Nvidia's GPUs became essential. The AI revolution couldn't happen without them. Nvidia became the indispensable arms dealer in a global AI gold rush. They designed chips specifically for AI workloads, monsters like A100 and later H100. Purpose-built silicon brains for AI, packed with features to accelerate AI's core calculations. They expanded CUDA with libraries like cuDNN, making peak performance accessible. Demand exploded, from startups to Google, Meta, and Microsoft, buying tens of thousands of GPUs to train models powering ChatGPT and other generative AI. Sales surged, profits soared, and the stock rocketed into the stratosphere. Nvidia never saw itself as just a hardware company. Jensen Huang knew the chip is only one part. The real power is the software that runs on it. Building a complete ecosystem is Nvidia's master plan. CUDA was the cornerstone and just the start. Then came the Nvidia AI platform and Omniverse for virtual world simulation. Best-in-class hardware plus indispensable software, a powerful competitive advantage. Developers trained on Nvidia tools are reluctant to switch. Rewriting code is costly and time-consuming. That stickiness gives pricing power and loyalty. They bought Mellanox in 2020, adding the nervous system that connects the brains, a more complete, optimized package. The attempt to buy ARM fell through, but showed Nvidia's ambition to be central to computing. As its role in AI became clear, investors piled in. Market cap exploded to over $1 trillion. A stunning ascent from making games look better to becoming one of the world's most valuable companies. Right bets, right time. Historic rewards. Nvidia's rise has been meteoric, but no king reigns forever without a fight. AI's profitability painted a giant target on their back. Competitors are coming from all sides. AMD and Intel are racing to build powerful GPUs and AI accelerators. Even major customers, Google, Amazon, Microsoft, design custom AI chips to reduce dependence. The race is far from over. Chips are cyclical and capital-intensive. Designs and manufacturing cost billions. Supply chain disruptions and export controls can hit revenue and create geopolitical uncertainty. Nvidia isn't standing still. They're investing in autonomy with Nvidia Drive, a brain for self-driving cars, expanding into robotics, healthcare, and scientific computing. Omniverse bets on a 3D internet for collaboration and simulation. So what's the lesson? It's a story about vision. Start with gaming, build a software ecosystem, pivot into data centers, and be ready when the AI tidal wave hits. True dominance isn't just fastest hardware, it's building the platform others use to create the future. Nvidia knows how to play the long game.